Hello everyone, what's up? Welcome back to my tutorial channel. It's Daniela Joan here, and today I'm going to show you how to tackle the test GRE general, the quantitative reasoning part. I'm going to show you the practice set. So for GRE quantitative reasoning, when you sign up for the exam, when you register for the exam, you're gonna have free access to the book GRE Quantitative Reasoning Practice that you can download from ETS account. And this is the one I got from the ETS account, and this is exactly the one that I practiced for the exam. So in this video I'm going to just show you a few problems because I don't want my video to be too long, and I'm not gonna focus on this area. I'm going to do the missed practice set that consists of all kind of questions. So first of all, to get you to how the GRE test is, we need to be familiar with the type of question. So here we have some example. These are not the question test yet, but to understand how to work on those questions. One of the types of question that you will see often on the exam is when you have to compare two quantity A and B, and there are four options. Either A is greater, B is greater, or two of them are equal, or the relationship cannot be determined from the information given. For example, if you look at example 1, quantity A is 2 times 6 and quantity B is 2 plus 6. So to do the basic calculation, 2 times 6 is 12 and 2 plus 6 is 8. So quantity A is clearly greater than B, so we choose option A. See that? Similar for example 2, quantity A is the length of PS on the picture, and quantity B is the length of SR on the diagram. So we see here in this, even though they look almost equal, but the question didn't give you any information to compare PS and SR. That's why we go for option D. PS and SR, the relationship between them cannot be established. Alright, so now let's work on some problems. I'm going to show you probably like 5 problems in this video. Alright, so let's look at problem number 1. Let me zoom in a little bit. Point R, S, and T lie on a number line, where S is between R and T. The distance between R and S is 6. The distance between R and T is 15. And we have to compare two quantity A and B. The quantity A, the distance between the midpoints of the line segments are S and T. B, the distance between S and T. So in order to compare them, I need to make the diagram, because without a diagram you cannot compare these things. So let's say it said like first of all you have to make the number line. My drawing is really bad. And then you have point R, S, and T lies on the number line, where S is between R and T. So I have to have R and T first. This is R and this is T. Then S should be somewhere between them, but they have a condition that's the distance between R and S is 6 and the distance between R and T is 15. So the whole length here is 15, Now R and S is 6, so it should be like this. This is S and this is 6. See that? So now look at the question. The question asks for the distance between the midpoints of the line segments. The distance between the midpoints of line segments RS and ST. So we have to find the midpoint of both of them, RS and ST. RS, the midpoint is right here. It should be the point that divides the length RS into two equal lengths in ST. So we have to find this distance. See that? This distance. So if you notice that RS is 6, so half of RS should be 3. So you got this is 3. And similar, you got ST. ST is 15 minus 6. That is ST. And this should be 9. And this is ST. Right? So half of ST is 4.5. So you got 4.5 is this side. So from this to this, it should be 7.5. So quantity A is 7.5. Now let's find quantity B. The distance between S and T. Between S and T, from S to T is 9. So you see that quantity B is 9 and quantity A is 7.5, leading to quantity B is greater. Yeah. Quantity B is greater. Now, so for this one, I'm going to go by B. See that? 1B. Alright, now let's go to question 2. S is a set of A numbers, of which 4 are negative and 4 are positive. A, quantity A, the average arithmetic mean of the numbers in S. B, the median of the number in S. So I'm going to clear my whiteboard. How do I clear it? Probably I just have to open a new page. Don't save. Alright. So the question asks for the average and the median of the number in S. For me, before I start verifying the solution, I have to make a guess first. For this one, I guess there's no way to determine the relationship between quantity A and B, so it should be option D. But still, we need to verify it through some example. So in order to prove that D is true, I'm going to point out 2 examples. One gonna show that A is greater, and one is gonna show that B is greater. So from then, I can make a conclusion that the relationship between A and B cannot be established. So let's find one set. Let's say example 1. I'm gonna find 8 numbers with negative 4 negative and 4 positive. So I'm gonna try some very close number. Negative 4, negative 3, negative 2, negative 1, and then I'm gonna have 100, 101, 102, 103. So now I have a set of A numbers, right? I have a set of A numbers. So if I take the average if I take the average, you see that the average should be, just add them all together. Hold on, let me find a way to show you. Let's say if I look at S as a number -4, -3, -2, and -1, with 4 positive numbers 101, 102, 103, and 104. So from here, I find the mean by add them all up and then divide it by 8. So like you can do it by hand, but I want to do it quickly, so I'm going to use a calculator, because on the exam you're allowed to use a calculator on the screen. You're not allowed to use your personal calculator. You only allowed to use calculator on the exam. So I'm gonna take -4 with -3 is -7, -7 with -2 is -9, -10. You have -10. So we got 101 minus 10 plus 102 plus 103 plus 104. That is the sum of all these numbers, and then you divide 8. So you got the average. The average is, where's my calculator? The average is 24.25. Now the median. The median is, first of all, you notice that I already created the set of A numbers in increasing order, ascending order. So the median of this set is basically the average between -1 and 101, because they're even numbers. There are 8 numbers. A is an even, so the median should be the average of the number at the 4th number and the 5th numbers. So the median is -1 plus 101 divided by 2. It should be 50. So in this case, this is quantity A, the average, and the median is quantity B. See that? And in this case, you see that B is greater than A. So this case, B is greater than A. Now let's try a different set. Let's say I have another set like this time I'm gonna make really big negative numbers. -101, -102, -103, -104. With some positive number, let's say 1, 2, 3, and 4. However, remember for negative, I have to rearrange this in ascending order. It should be -4, -3, -102, -101. All right. So now, the average should be just the opposite with the oh, my bad. Oh, my bad. The average here should be -24.25. Average is -24.25 because these numbers just flip sides. Then the median of them is no longer 50, but it should be the average between -101 and 1, so it should be -50. And in this case, -24.25 is quantity A, and this one is B. See that? So in this case, you notice that A is actually greater than B. So from these two examples, you see that it's not always true that the average of this set is greater than the median, and it's not always true that the median of this set is greater than the average. So to answer the question number 2, the answer should be D. The relationship between quantity A and quantity B cannot be determined. So 2, I'm gonna go by B. And now let's go to problem number 3. The length of each side of a rectangle R is an integer, and the area of R is 36. Quantity A, the number of possible values of the perimeters of R. Quantity B, 6. So the only way that we can find the answer is just work the problem out completely. There's no guess in here. Alright, so first we have 2 pieces of information on this question. The length of SI is an integer, and the area of R is 36. So I'm going to use my whiteboard again, and I'm going to erase the old board. Here, this is a rectangle. Oh, my bad. Okay, now I'm going to use my pen. This is a rectangle. Let me use different brush. This is a rectangle. See that? And the area is 36, right? The area is 36. 36 is the area. And remember that the size, the length of the size are integer. So first of all, you're gonna factor 36 into the product of integers. So, and another thing you have to keep in mind is the length of the side cannot be negative. And 36 here can be either 1 times 36 or 2 times 18. Or, hold on, I'm going to use different ways to express this. So we got 36 here is either 1 times 36 or 2, 18. Or 3, 12, or 4, 9, or 6, 6. You also can have 9, 4, but they just the same. They just turn the rectangle to different direction. So here we have like 4 pairs, right? Is it 4? No, we have 5 pairs. 1, 36, 2, 18, 3, 12, 4, 9, 6, 6. So for the first pair, we got the perimeter. The question asks for the perimeter. So the first pair, the perimeter should be 37 times. Remember, perimeter is the perimeter is 2 times A plus B, where A and B are the lengths. So for each of these, you're gonna have 1 plus 36 is 37 times 2 is 74. Then 2 plus 18 is 20 times 2 is 40. 3 plus 12 is 15 times 2 is 30. 4 plus 9 is 13 times 2 is 26. 6 plus 6 is 12 times 2 is 24. So we have 5 possible values of the perimeter. We got 5. So quantity A. So quantity A is 5. And quantity B is given as 6. So it's clearly shown that B is greater because 6 is greater than 5. I repeat why we got 5 here, because we have 5 values of the perimeters. So that's why we got 6 is greater than 5. Alright, so from here we have B is the answer. B is the answer. Now let's move to question number 4. X is equal to z minus 1 whole square and y is equal to z plus 1 whole square. Quantity A, the average, the arithmetic mean of x and y. quantity B is z squared. So for this problem, we have to solve it out. I'm going to use my whiteboard again. Let me erase it. Don't save. So let's just write down here. X is z minus 1 squared. Hold up. I'm going to make it smaller because I don't need it big. Anyway. So x is z minus 1 squared, and y is z plus 1 squared. So the average between x and y, the average should be 1/2, or you can say 0.5 of x plus y. That's the average. And it should be equal to, let's say, (0.5) times what? Z minus 1 squared plus z plus 1 squared. Z minus 1 squared and z plus 1 squared. And we have to compare with z squared. So let's just derive it. Let's just derive it. I'm going to call this the average. I'm going to call this the average A. So we got A is equal to 0.5 times what? I'm going to derive the whole thing. So it should be z squared minus 2z plus 1 plus z squared plus 2z plus 1. Okay, and it should be 0.5 times what? Now z squared with z squared is 2z squared, 2z squared, and then minus 2z with plus 2z cancel out and plus 2. Now we can time 0.5 into each of these components. We got 0.5 times 2z squared, just z squared, and 0.5 plus 0.5 times 2 is 1. So quantity A is z squared plus 1, and quantity B is given as z squared. So it's clearly shown that A is greater than B because A is just B plus 1. So A is the correct answer. See that? So for this problem, A is the correct answer. Now the last problem of today. I'm gonna do just 5 problems every day. X, Y, Z are the lengths of the sides of a triangle. X plus Y plus Z, and quantity B 2Z. 2Z. Right. For this one, it's clearly that the relationship between them cannot be established. But in order to prove my point, I have to show to you 2 examples. One showing that quantity A is greater than B, and one example showing that quantity B is greater than A, to prove that the relationship between A and B cannot be determined. So let's say I'm a user the whiteboard. Let me erase it again. So let's say if I want to look at a triangle, and I'm gonna say this is X, Y, and Z. Quantity A is the perimeter, and quantity B is just 2Z. So I'm gonna show you one example that A is greater. in one example is B is greater. So in order to show that quantity A is greater, I'm going to pick a very small z. Let's say a very small z. A very small z. Let's say z is 1. This is z. This is z. And let's say this is 12. And this is 12.5, for example. So from this one, you see that the perimeter is for sure greater than 2. So this example, A is greater than B, right? A is greater. Make sure that the triangle exists. Make sure the triangle exists. Make sure the triangle exists. And let's find another triangle that's showing the difference. So in this case, you see the perimeter. In this case, what? The perimeter is 25.5. Right, 25.5. Now I'm going to show you an example that 2 times what the side is greater than the perimeter. No, I think let me use different whiteboard. In order for a triangle to exist, remember that x plus y is always greater than z, right? Remember that. This is in order to have the triangle exist. We got a set condition, and one of them is x plus y is greater than z. So let's say if we add z both sides, so we got x plus y plus z is greater than 2z. It's satisfied for all cases of x, y, and z as long as the triangle exists. So for this one, quantity A is greater than quantity B. I apologize. My first guess was wrong. It should be A is greater than B because x plus y plus z is always greater than 2z. So the correct answer here is A. The correct answer here is A. Alright, so that's it for today. Thanks so much for watching. I hope you guys enjoyed my lesson. See you tomorrow.